Today we want to look at physics. So our tutorial question will be based on a physics question, and the question goes thus: a body starts from rest and travels in a straight line for 2 seconds with a uniform acceleration of 1 meter per second square. It then travels at a constant speed for some time before coming to rest with a uniform retardation of 2 meters per second square. The total distance covered by it is 15 meters. So question 1 says, draw the velocity time graph for the motion. Question 2 says, calculate the velocity attained at the end of 2 seconds and the total time taken for the journey. Now, generally taking a look at this question, we are looking at a linear motion using a velocity time graph, which means we are going to be using a velocity time graph to solve it instead of using the formula method. So although the formula method will still come into play, but everything we have to do will come from the velocity time graph. So let's go to the first question, which is for us to draw the velocity time graph for this motion that we've read to us. All right, so a body starts from rest. Now, okay, so let's start. So we have a velocity time graph. So this is what we will have. We have something like this. So we have this. So this line here is for our velocity. So we put the unit, the symbol is V, the unit is meter per second, and this region here, this horizontal line, is for our time, which is in what? Which is in second. Okay, and the region here where they meet is our what? Is our 0. So let's now interpret this question and put it on on the velocity time graph. Okay, so a body starts from rest. Now when they say a body starts from rest, which means the initial velocity is what? Is 0. So it means the body starts from this origin here, which is 0, and our initial velocity, as we all know, is u. So it means at this point, for this first statement, we start from rest, initial velocity is what? Is 0. Okay, so we draw it. So start from rest in a straight line, and it goes. So let's say this is where it reaches in a straight line. So this is our straight line for 2 seconds. So this is our, so which means the time it takes for the body to move in a straight line is 2 seconds. So we denote this side. So this is our 2. So that's the movement of the body. It takes 2 seconds. So let's say this is what we have, with a uniform acceleration of 1 meter per second square. So which means it accelerates. So the acceleration, you can see this point here, our A, this is the symbol for acceleration, is what? 1 meter per second squared. Okay, all right. So when we have this, okay, so this is what we have for this first statement. Then it then travels at a constant speed for some time. So this is our region for our velocity. So it travels what? At a constant speed. So for a constant speed, this is how it will go. It means it goes, the speed is what? Is constant. There's no change in the speed. After it has accelerated, then it moves with a what? With a constant speed. What? For some time. Now the time it using moved for that constant speed, we are not given. So which means we say that what? We can say that this is our what? Our t. Let's put it at t, or let's say t1, as the case may be. T1 for some time before coming to rest with a uniform retardation of 2 meters per second squared. So the body moves with the constant speed, then it comes what? It comes to rest with a what? With a retardation. So this is a retardation. This is a retardation. So and with a retardation of 2 meters per second square, which means our A equals to 2 meters per second square. So this is our T2. We are not given the time it's used in what in for the retardation. But we are given the acceleration. We are also given the what? The retardation. Okay. Alright. So for this question now, this is how the velocity time graph will look like. A body starts from rest, which means from the origin, and it accelerates with 1 meter per second square at what for 2 seconds. It moves with a constant speed at a time t1, which we don't know. Then it decelerates, or it retardates at it's a retardation of 2 meter per second at a time 2, which we don't also know. Okay, so this is the velocity time graph for this question here. Now for this statement rather. Now the question, we've already drawn this, we've done this one. So this one is we've done it. Okay, so let's mark it. Now let's move to the second question. The second question is now saying calculate the velocity attained at the end of 2 seconds. Calculate the velocity attained at the end of 2 seconds, which means we want to calculate for this velocity here, this and what for these 2 seconds that the body accelerates. Okay, so for us to be able to do this, since the body starts from origin, this body starts from rest, and I said when it starts from rest, which means it starts from origin, and the initial value is what? Initial velocity is what? Is 0. So the final velocity is what they want us to calculate for, which we don't know yet. Okay, what are we also given? We are given the acceleration. The acceleration is what? 1 meter per second squared. Okay, and the time for the body is what? 2 seconds. So the next thing is now for us to know what? Use our equation of motion. Looking at the equation of motion, which of these parameters we going to use for the equation of motion? We have the initial velocity, which is 0. We have the final velocity, which is what we are looking for. We have acceleration, which is 1 meter per second, and the time, which is 2 seconds. So from what we have, if we still remember our equation of motion, okay, maybe for reminder's sake, let's put them down so that we should be able to we'll be able to pick the one that suits the parameters given in the question. Okay, so let's write down the equation of motion. So equations of motion of linear motion. So this is a linear motion, which means a motion in a straight line. So we have v equals to what? U plus at. We have, what do we have there again? We have v squared equals to u squared plus 2as. What do we have again? We have s equals to ut plus 1 over 2 at squared. Then we have s equals to what? Equals to v plus u over 2 bracket times t. Okay, so these are the equations of linear motion that we have. So taking a look at what the equation of motion and the parameters we have here, so it can be deduced that looking at them, we are looking for v, we have our u, we have our a, we have our t, which means we can use this. Let's see whether we can use this. Can we use this? No, because our s, although our s is given, but we are not okay, our s is given. Possibly we can use this. What about this? Okay, we want to look for the final velocity and not distance. This one also, okay, can we use this? Okay, possibly we can use this, but the one that is very clear is what is this. So we pick it. So we are going to be using V equals to what? U plus AT. Okay, so V equals to U, which is what? 0, plus our A, which is what? 1, times T, which is 2 time, which is 2 seconds. So V equals to what? 0 plus 1 times 2, that's 2. So it means what? The velocity at 2 seconds is what? 2 meter per second. So this is our velocity attained at the end of what? 2 seconds. So this is the answer to that. All right. So now let's move to the what? To the final question we have there. Now, total time taken for the journey. So we want to calculate for this the time taken, the total time taken for the journey. Here we have 2 seconds. Here we have a T1. Here we have T2. So it means we have to look for T1. We have to also look for what? T2. We now add them together. So that will give us our what? The total time taken for the journey. So how do we go about this? Now, there are 2 ways we can use to do it. The first way we can use is what? We divide this shape here. That's the area covered. We divide it. This shape, we look for the area. This shape, we look for the area, and this other shape, we look for the area. And from there, we add them together, and we do the necessary thing. So from what we are going to do, let's divide it. So this will be our what? This will be 1. This will be 2, and this will be what? 3. Okay. So we do them stage by stage. Then whatever we get from there, we add them together. Okay. So let's quickly look at them. Okay. So now for us to be able to do this, we will say what? Distance covered equal to what? Area under let me see, area under the, should I say under the curve now? Okay, let's put it that way. Area under the curve. So what this means is that what? We want to be looking at the area for, since we said we want to differentiate, we want to divide the shapes. So we look for the area of this shape, we look for the area of this shape, and we look for the area of this shape. So that will be equivalent to our distance for each of the shapes. Then we add them together. So the first shape we are going to be looking at. So the first area. So if you look at the first, this first one here, this shape, this is a what? A triangle. And the area of a triangle is what? 1/2 times base times what? Height. So from there we can say that what? Excuse me. So we have what? 1/2 times, what's our base? This is our base. So from here to here, which is what? Which is 2. So which is 2 times height. Our height is from here to here, and that's equivalent to our what? Our velocity. And our velocity is what? Is 2. So we put it there. So it means what? We divide this. So it means the area of the first triangle is what? Is 2. So it's 2. Okay, that's the distance now, because we are saying that what the distance covered is equal to area under the curve. So which is what? 2. Okay, Now for the second one, the shape is a what? The shape is a rectangle. So area of a rectangle is what? Length times breadth. So what's our length? What's our length? So this is our length times breadth. So our length, our breadth. So that will be giving us we're having 2 times the breadth, which is what? Which is t. Which is t, because the breadth will be from here to here, and we don't know it, and we call it t1. That's what we will call it. Okay, all right. So then we look at the third one. Area of a what? Of a triangle. Area of a triangle, which is the same thing as what? 1/2 times base times height. Okay. So looking at what we have here now, with this shape here now, we are given a retardation of what? Of 2 meters per second square. That's what we are given. So what do we do? For us to get this T2? We should be able to get this T2, since we are given the retardation. We are also given the velocity. So let's calculate for this T2. Now there's something you should take note of. The difference between acceleration and retardation. Acceleration. So when they say a body accelerates, what are the parameters that will be there? And when they say a body what? Decelerates, what are the parameters that we are going to be looking for? Now when they say a body accelerates from rest, when they say a body what? Accelerates from rest, so it means what? Your initial velocity, so let's say accelerate from rest, it means your initial velocity u is 0. So that's the standard. Initial velocity u is 0, and our final velocity v, so it will be given to us, or we need to calculate it just from what we've done in the question. So when they say a body decelerates to rest, what does that mean? It means that what? Your initial velocity u will be u, or it will be equivalent to what? To v, if it is given, or it will be equivalent to what? To the constant speed, which is given to you. Then the final velocity v will be 0. So these are the things you should put at the back of your mind when you are given something like this. When they say a body accelerates from rest, it means the initial velocity u is 0. Then the final velocity will be given to us, or we have to calculate for it. Then if it decelerates to rest, it means the initial velocity u will be equals to u, or it will be equal to the what? To the constant speed, which is given to us in the question. Then while the final velocity v will be equal to 0. So in this scenario now, we have the retardation, or we say deceleration. Retardation and deceleration, they are the same thing. So we have the retardation and we have the what? We have the speed. So it means for us to be able to do this from here, using the equation of linear motion I wrote previously, we can calculate for what? For T2. So which means we should be having v equals to u plus what? AT. And again, there's something you have to take care for just what I've just rub off now. There's something I need to add. There's something I need to add. So when it accelerates, the acceleration will be positive. When it decelerates, the deceleration will be what? It will be negative. The value of the deceleration will be negative. So it means here now, since from what we've said earlier, we want to, so for this place, for this shape here, our velocity, since it is retardating, our velocity will be what? Will be 0, which will be equal to, so our u, which is the initial velocity, will now be equal to the constant speed which is given to, which we calculated before, and that's what? That's a 2. Then plus, now since it is retardating, our a, so it will be what? This retardation, it will be minus. So it will be minus 2 times what? T2. So from here we have 0 equals to what? 2 minus 2t2. Alright, so with this, let's rearrange. So we'll be having 2t2 equals to 2. So divide both sides by 2. So t2 equals to what? 1. 1 second. So what this means is that what? Our t2, which is this portion here with the of retardation, is what? Is 1 second. So with this, we can now come back to this place. We can come back here and input our values so that we'll be able to get the distance for this third shape here, which is our triangle there. So it means what? We'll be having 1/2 times, what's our base? Our base is here. So which is the time from here to here, which is what we've calculated, which is 1, times our height, which is what? Which was 2. That's our height. Okay, so with this, we divide. So here we'll be having what? We'll be having 1 as our answer here. Okay, so which means we've already known the distance covered for this portion. We have the distance covered for this shape here, and we have the distance covered for this shape. So all what we now do is what? We are given the question, we are given the total distance covered. So what do? We now do total distance covered so to know the total time. The total time is what we want to get, but we have to go through the route of what? Getting the total distance. So the total distance covered equals to what? Distance of this, so is a distance from 1 plus distance from 2 plus distance from 3. So it means the total distance covered will be equal to distance from this one, distance plus distance from 2 plus what? Distance from 3. So that will now give us, in the question, the total distance covered is 15 equal to distance covered from 1, which is this, so which is what? Plus 2 plus distance covered from 2, which is what? 2 times t, so that's what? 2t1 plus distance covered from 3, which is what? Which is 1. So here, let's collect like time. So we'll be having 15 minus 2 minus 1 equals to what? 2t1. So 15 minus 2, that's 13. 13 minus 1, so that's what? 12 equals to what? 2t1. So divide both sides by 2. So t1 equals to what? Equals to 6 seconds. T1 equals to 6 seconds. So the total time for the journey equals to what? The first time is what? Is 2 plus T1, which is what? 6 plus T2, which is what? 1. So the total time is what? 9 seconds. So this is the answer to what? To the second question, which we were asked to calculate for the total time journey for the what? For the body. So that's where you have it. So any question you have, just put it in the comment section. I'll be right there to what? To